Hey, what's up guys, my name is Cherno and welcome to episode 12 of the Sparky Game Engine series. So today we're going to be covering a little cool thing called transformation stacks. So let's just open up the drawing board and begin. Where are you? So I finally updated Mischief, by the way, so it won't be begging me to update it every 5 seconds. That's good news. Okay, so what is a transformation stack? Well, basically what we want to be able to do is say, I think almost the best way to equate this is probably just to be like, the best way to explain it would be to compare it to kind of legacy OpenGL's push and pop matrix. That's probably one of the best ways to explain it, but for those of you who don't know legacy OpenGL, that's not going to help you, so I'm going to kind of explain it from scratch. Basically, picture this scenario. We've got 5 sprites. Well, in fact, picture this scenario. We've got 5 sprites, yeah? I'm not actually going to write them. I'm going to draw them instead. In fact, I'm going to draw them in blue or teal. So we've got 5 sprites, not that closely together. We've got 5 sprites which we want to submit, right? Let's just say that they're not all circles. Let's just say that one of them is, for example, the background of like a menu, okay? Maybe we've got 2 menus. We've got one over here, okay? And these are 2 backgrounds for them, right? So what we want to do is we want to submit this into the renderer because we need to render these 2 backgrounds. So basically picture it this way. I'm probably not explaining this very well. This is the window, this black border, and then we want to have kind of 2 lists of backgrounds, for example, right? And then 2 lists of items, and we want them to have some kind of colored background. Maybe one's teal and the other one's also teal. So we've done that, right? And now what we want to do is submit them to the renderer so they get rendered. Next, what we want to do though is we want to actually have like maybe text in each of these, right? So we want to have buttons or like text or something just drawn in each of these, yeah? We want to be able to specify these things or these lists or these components relative to basically their parent component. So what we want to do is we want to apply both the transformation of this, whether it be rotation, just normal translation, or scale, whatever, yeah? We want to apply the transformation of this background to these buttons as well, so that we can just be like, I want a background to be at 500, if we're just living in 2D space, 500, like 100, right? So maybe that's this point up here. And then I want a button inside that to be at 50-50, right? And what will happen is in turn, this button here, so this is the button, this is like the background. They both begin with G, so I'm just going to say, I was going to say box, but that also begins with B. Oh man. Button and background, I'll just write BG and BU, right? So this BU will basically have a transformation of 550, 150 applied to it, right? In terms, but you specify its position like that. So the way this is going to work is when we do something like, I'm going to, for example, specify all of the components inside this. What I do is I push, we have a background, we submit it to the renderer, we push a matrix, which is a translation matrix, which is 500, 100. We add all of our buttons to the renderer, and then we pop that matrix so that we go back to normal, right? So when we push it, we go from here to there. When we pop it, we go from there back to here, right? Does that make sense? So that's kind of how this whole thing works. And of course you can push multiple times and you can pop multiple times. So because we do this stuff, how it's actually going to be stored underlying kind of under everything is going to be in a vector of just matrices. So a vector of mat4s. I don't know why I wrote that in capitals because it's not actually in capitals, but a vector of mat4s, okay? So what happens is when we push, yeah, we push, this is another thing that is probably worth discussion at this point. When we push one matrix, so let's just say we push this one, and then suddenly we've got a button, as I said, at 50-50, and inside there might be text at, say, 5-5, yeah? So if we have this kind of 1, 2, and then, oh my goodness, there's a third kind of matrix, what should happen is this thing obviously has to have this and that applied to it. So it has to be 555155, yeah, for the piece of text if it's inside here. So in order for that to work, when we push, we don't simply push back a matrix into this standard vector, right? That's not what we do. We have to multiply the new matrix by the last matrix that was in here, if that makes sense. So for example, a good way to do this is if we had a push function which took in a mat4, we would basically just say, and that is terrible, we would basically just say that let's go ahead and take our vector, which is this data structure here, and then we'll push back the back of that vector times this mat4. And that would kind of be how it works. So we actually need to multiply it. If we want to push a brand new matrix to the stack without popping everything, so for example, we might want to have all this stuff, but suddenly in the middle we're like, actually I want to push another component that's relative to just nothing, we can do something called a push override. I don't know if we'll put that in today because it's probably not that useful. I mean, it is, but I think we can live without it for now, for the sake of simplicity. So that's kind of the idea, okay? We want to be able to have that function out, and then of course when we popping is much more simple. So when we pop, we don't specify a matrix. All pop does is it literally calls v.popback, and that's like it. So it'll just remove the last component from the last matrix. So that's the whole transformation stack thing, okay? It's not too difficult. It's handled by the renderer, and of course, when we go through this, we have to grab whatever... Oh, and one thing I should mention as well is that this vector always has one component, because you might be like, well, what if I push back like my first matrix? What is v back? Like, what's going on? So this will always have one component, and that will be the identity matrix. And by component, I mean matrix. So this vector will always have one matrix in it, and that will be identity, okay? So what happens, of course, if nothing is on the stack, the identity matrix will be multiplied and we'll be all good. So now that we've got this data structure of matrices, how do they actually affect our components, right? How do they actually affect all of our renderables when they get rendered and when they get submitted? Well, what happens is when we go into our submission code right over here, and this might be easier just to show in code. So if I open up our batch renderer, for example, we've got all of these vertices, right? All we have to do is just multiply this vertex, which is a vec3. So we don't actually have a way to multiply mat4s by vec3s yet. So we need to definitely add that into our matrix class. But what happens is for each of these vertices that we have here, we need to basically multiply the position, or have basically the position, oh, I should say, yeah, multiply the position by the whatever the matrix is. So it'll be actually the other way around. So we'll multiply the matrix by the position. So if I had a matrix of translation 5, 5, for example, I'd have to multiply that with the position, which would give me my new position, okay? Now the other question that I assume many of you might actually have is, why can't they just be vectors? Why can't I just be like, why do I have to push matrices, right? Why can't I just say, you know, if all you want is this kind of translation where you just have all this stuff and it's relative to other stuff, why not just have a vector of vec3s, right? And then all you'd have to do is be like, oh, let's push back a vector of 500, 100, right? Which means that if I do 50, 50, it will be 500 plus 50, and we'll actually get into our same position. That's totally okay, and that will work for that, right? It will not work when you have things like rotation. Okay, if I want to rotate a component suddenly and have things relative to that rotation, which is very, very common, by the way, there's no way I can do that with positional vectors, whereas of course matrices are capable of storing rotation. Same thing applies to scale, okay? So that is the huge idea. Okay, cool. So that's the general plan. And yeah, I felt it was probably necessary to explain that vec3 thing because some people might not understand why you can't just do that. So that is why. Because we're not, remember, the transformation stack is a transformation stack. It's not a translation stack, right? It's a transformation stack, which means that it handles any kind of transformation, including rotation, scale, not just translation. All right, cool. We're ready to begin. So in case you didn't catch up with what we had last time. We had layers, which means that basically that pink sprite versus the background is on 2 separate layers. We're running in debug mode now, which is why the performance is so terrible. In fact, let's quickly cover, since we're over here, let's cover a way to increase debug performance. So currently our debug performance is not really acceptable, especially because release mode runs at about 750, I think, frames per second. One quick way that we can speed up debug mode, and the reason you want to be in debug mode, by the way, is because you want to be able to check things out. So a quick example would be something like if I put a breakpoint here and I'm in debug mode, I get to see everything that's going on. I can see these shaders, I can see these layers, I can see everything these layers contain. Everything's totally okay, the size is fine. Everything I have is actually properly kind of available to me. The problem is once the compiler optimizes certain things and inlines them and does all this crazy stuff, it's going to be harder for you to read variables because they've changed so much. So, for example, you can see that our renderable size is 416. It's clearly not correct. And the reason it's done that is because all this optimization has occurred and it's not actually just available for us. So it's terrible for debugging, but it's beautiful for actual release, hence the name. So one way we can just speed up debugging a bit, because our debug mode is running very, very slowly right now at 34 frames per second, is we can drop into properties, and there is a setting under... I think, let's just find it somewhere. It's here somewhere. No. Where is it? Let's just search for it. Enable. It's here somewhere. Where did it go? I'll find it. Don't you worry. It's here somewhere. So let's see. Code generator. Yes, basic runtime checks. So it's set on default. We don't want that. It should be on uninitialized variables. Okay. If we do that, we should run significantly faster, but we're not. Okay. Well. That was fantastic. Are we on oh, it's because we're on release. So this should be on default. I should have probably... because it should be on both by default. So let's change this back to debug. And change it from both to uninitialized variables. Okay? Now, take 5 of this. I'll have to recompile all of our code, obviously, with these new settings in mind. It should be quite faster. Okay? And we basically shouldn't have lost our functionality. So if I place a breakpoint here, we are in debug mode, and we should have the size being like proper and everything. So it should be totally okay, basically penalty free, but we have much faster performance. Okay, cool. So that's just a quick tip for dealing with debug mode. All right, let's begin with the transformation stack. So if we just go into batch renderer. Really, every renderer should have this, okay? I'm just going to quickly check out the simple renderer and see how... is this simple renderer? Wow, that is simple. it's like 30 lines of code. Yes, so it might be a bit difficult with the simple renderer because the sprite's position... Actually, no, it won't be. There's a translation, and it sets a model matrix for it, so yeah, it'll be totally okay. Good. Now, back to our renderer. So, our renderer now should have a protected standard vector of mat4s. Okay, and we'll call this transformation stack. All right, nice long name so that everyone can understand exactly what it is, which is the plan. Okay, great. So now that we've got that, if we dip into our... oh, sorry, well, we need to add functions to this, clearly. So, over here we'll have, and these don't need to be overridden at all, I'm pretty sure. I can't really think of a circumstance in which you'd want to override them. So we'll have void... so push, okay, and I guess we should probably just expect them to be like, we don't have to call it push matrix, we'll just call it push. So we'll have push and pop, right? Because they take in a mat4, so you'll be like, oh, I totally know what's going on. So we'll implement them here. So all this has to do, remember, is it doesn't simply go m transformation stack dot push back matrix, okay? One thing I should probably mention is the fact that when we create a, so we'll make it over here, we'll have a renderer 2D, we'll have a constructor. So this constructor, all it will do is it will go m transformation stack dot push back maths mat4 identity. All right, cool. So now we've got at least one thing in there. Now the reason this should actually be private. So the reason this is completely private and everything is because, remember, we don't want to pop back if we can't pop it too many times, because if we keep pop backing and we actually pop this identity matrix, things will happen and they will not happen, that they won't be good. So when we do this, we want to basically take our back thing, which is m transformation stack, thanks for removing matrix, bro, dot back, right, time, which is the last element. So dot back is the same thing as just going that. All right, so that is the same as dot back. So we're multiplying our last matrix, which will be identity, for example, by our normal matrix, and we're pushing that result in. Okay, very important. Now that's push. So pop will be a bit different. Pop won't obviously take in anything. Pop is just supposed to pop back, okay? But to avoid doing this multiple times, because we definitely do not want to do this multiple times, we have to check to see if the transformation stack's size is greater than 1, then we will pop back, okay? Because if it is 1, it means we've just got the identity matrix in there. We want to avoid popping that, okay? Cool, that's it. You can throw some kind of exception. Once we have our logging system, I'm definitely going to, I'll probably just scramble to-dos or everywhere, because we don't have a logging system yet. The reason I'm not really concerned about that too much, I'll hopefully get it in before Let 'em Dare, but the reason I'm not concerned with it too much is just because it's not really a cutting edge feature. It's more of a debug feature, obviously. It's not something that we actually need. It's something that will help us develop. So that's why it's not a high priority feature. Fortunately, you guys are going to have to get used to that. Stuff that is good for developers, but not for the customers, or the, I should probably say, since this is going to be free, obviously, this game. I should say the user base, or whoever plays, all the players, stuff that is useful to developers but not players. The players will obviously have the higher priority. So that's an important thing to note, but that is the idea. Push and pop. Cool, that is done. If we wanted to have push override, we might as well put that in there. So we'll have a push override. Okay, so a push override. In fact, I might just do this. I'll have a push, and then we'll have a bool override equals false by default, okay? One thing you can do in C++, and you can't do this in Java, you can do this in C#, but one thing we can do is we can specify defaults to variables as long as they're on the end. So if it's the last parameter, you can specify default for it, which means that right now this is equivalent to me having 2 of the same function, one that takes in 1 parameter, one that takes in 2. So by doing this, I'm basically allowing people to just use push with just specifying a matrix, and that's it, no second parameter. And if you don't specify a second parameter, it will be assumed to be false, okay? That's useful because what I want to do is, if override, I want to, so we'll have an else, okay? So if it's not overridden, I want to do this. If it is override, I basically want to do the same thing, except I don't want to multiply it. Okay? So, that's the idea. Alright? So if we, and again, as I said, the reason we might want to do this is because we want to get back to our identity, basically, but we do not want to pop everything off. We just want to push this one, do something quickly, and then pop it. Okay, cool. Right. That looks pretty good. So that's pretty much the extent of our actual kind of handling of our transformation stack and how it kind of works behind the scenes and how push and pop work, okay? Now, to actually implement it, the thing that has to implement it is the actual renderer, okay? Because every renderer does things uniquely. It is important for the actual renderer to implement this stuff itself, okay? So you can't just generally be like, oh cool, I'll implement it and everything will work. No, the actual flush or usually submit will actually have to use that transformation stack to transform its vertices. So what I can do, or what I have to do now in batch renderer, the C++ one please, is in our submit, which is what does all of this fun stuff, we need to go ahead and basically grab the current matrix from our stack of matrices, okay, so the back one, and multiply it with the position, and that will give us the vertex. So basically, just to show you an example, is we have to go m transformation stack. Oh, I made it private. Let's go back. Yeah, I should have made it private. It should be private in the sense that nothing should modify it except for this, but we obviously need access to it if we're in here, so we'll make it protected. All right. Note, I'm still keeping this protected here because that's actually like a method. I like to separate variables and methods by something like this. So there you go. All right, cool. It's just like a little kind of code style convention thing. Okay, so we want to grab m transformation stack. That is not what I wanted at all, Visual Studio. Dot back, okay, and multiply it with position. This should give us a vec3, okay? Right now it's invalid because you can't multiply matrices with vec3s, but we'll figure that out. So let's quickly cover how that's going to work. This whole multiplying with vec3s, how is mat4 versus vec3, what's going on? So one thing that you would know if you went to school and learnt about matrix maths, just in general, not in graphics programming, is you can multiply, if we've got a 4x4 matrix, yeah, we can multiply it with something like a 4x1, okay? As long as these two numbers are the same, you can multiply it, okay? We don't really care about these too much, but these two have to be the same. So if this is, say, rows and columns, then it has to be multipliable against this. Now, clearly we do it a bit differently. We do column major, so we'll have columns and rows, columns and rows. So the rows of this, yeah, so if we have a 4x4 matrix, the rows of the matrix, which is this part, has to be the same as the column count. So the number of components has to be the same, okay? It is, because we've got a 4x4 matrix, so clearly we do have a row that has 4 components, and we've got a vector 4, for example, which has this. Now, can we do it against a 3? No, we can't. We can't do that. You can't actually multiply a 4x4 matrix with a 3x1 matrix, or just a 3-component vector. You can do it with a 4. Now, since we've got a 3, all we have to do is basically not change the last component. So we assume the last component to just be 1. So if we have an actual vector, a vec3 would look like something like this, right? But we add a 4th component where it has 1. That way we multiply a 1 with it, and everything is the best. Now, is it worth converting a vec3 into a vec4? No, that is not a good idea in terms of performance. So we want to basically, that this is just kind of the behind the scenes, I'm assuming this is how it works kind of thing, just so you guys know how it works, okay? All we're going to do is, and I'm not assuming this is how it works, this is how it works. But what I should say is, this is just something to let you guys know how it's actually going to work. But the idea is, when we do this, we basically, and the way that matrix multiplication works, everyone should know this, by the way, I've covered this a million times in other videos, and if you've done maths, you would know this. We basically take the row and we multiply it with the column. So we take each row and multiply it with the column. That's how it gives us the answer. So a 4x4 times, so if we had this, right, and we had A, B, C, D. I should do this in column major though. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P times xyz1, okay, that will give us a vec4, okay? So what will happen is we will multiply each column by, well, we'll multiply each row by each column, because we can't, there aren't columns here, there aren't rows here, each row, and then that multiplied by that will give us our first answer, okay? So that's the idea. So basically, because we're about to write this, but I want you guys to understand it, is a times x plus c times y plus I times z, right? You guys are getting the pattern, plus m times 1 plus m times 1 is going to equal our first answer. So I'm just going to write A1, answer 1, right? That's how it's going to do it. Now the second thing is going to be the same. It's going to be B times X plus F times Y, etc., right? And that will give us A2, and then so on and so forth to give us these three things. Now, since we don't have a fourth component and we're just dealing with this, the fourth component will still kind of exist, but we're doing two things. A, we're not returning the fourth component, but we still need to do something with this fourth row. So we just imagine that the fourth row is essentially just 1, okay? So the idea kind of is just that we basically just add on that fourth row instead of multiplying it with something, okay? And you guys will see that when we actually implement it. So that's it. That's how simple this thing is. So if we go into mat4, because we need to include this stuff in our mat4, what we want to do is we want to add, and you can call this whatever you want. I'm just going to basically make it a multiplication operator, which returns a vec3. So it's going to be a vec3 operator multiplication thing, which will take in a mat4 and a vec3. Okay. So it's yes, and we're taking let's change this around a little bit, because right now it's taking in a mat4. It's going to return, so this is going to probably return, let's see. So this is going to return a vec3. It's going to take in left, and it's definitely not going to modify that either. So how did we have this set up? Let me quickly just check. Left dot mult, so we had a dot multiply. Oh, I see. The problem was it returned, yeah, it returned this. That's why we had it set up like this. So because of that fact, let's just rewrite it as this. We'll return a vec3. It won't be a yeah, I should say it won't be a it won't be returning a reference clearly because it's returning a completely different class, which probably drop this down as well. But it will take in we know that the mat4 is our current one, so it'll just be the other one, okay? So with vec3, it will kind of work the same, except of course, we aren't modifying left versus right anymore. We're returning something brand new, so we definitely should be passing this by reference. But there we go. That's kind of the idea, and we will not have a times equals because clearly our result isn't a mat4. So that's our transformation kind of vec3 multiplies. Vec4 multiplies will work the same way. In fact, I'm thinking we might as well just add that in right now because it'll be useful in the future, and since we're on this topic, it will be totally okay. All right, cool. So there we go. We've got a bunch of methods to implement now. Let's go ahead and implement them. So we'll deal with the multiplies first. I'll probably deal with vec4 multiply first because that's kind of what vec3 multiply is, except with the thing. But if we go into mat4, here's our multiply. Okay, so vec4. Okay, so this is going to multiply the current matrix by this, but it's not going to affect the current matrix, clearly. One thing I should probably note is that these definitely should be const, okay? They shouldn't be affecting, that is const, but it shouldn't be affecting the actual matrix at all, okay? It should just be creating a new vec4, okay? So basically we can just kind of return this as a vec4 like this. We don't have to actually create a vec4 called result, and then we can do each row here. So as I covered over here, we need to multiply each column by each row by each column, and then add it as an answer over here. So to do that, we've got a few options. We've got two ways of accessing currently. We can either do it by columns or by elements. I want to use columns. It'd probably be a bit more simple than elements, because with elements we'll have to do something like elements 0, and then the next one will be elements 4, but since we're going across the row, right? So it might be better just to say let's see. So columns 0. So that'll be the first column dot x times other dot x. Is that right? That's right. Plus columns 1 dot x, right, times y, plus, whoa, too far, plus columns 2 dot x plus other dot z, plus columns 3 dot x. Okay, and that is our first one. All right, that is our very, there we go. That is our very first one. So for the others, it's going to be very simple. This is just, oh my goodness, my hands are just slopping all over the place, all over this keyboard. This will just go ahead and be changed into what? No, sorry. I meant to do this. And also I've got Z twice. Everything is just all over the place. Y, Z, W. Why does insert delete 2 characters? Why are you doing that? Y, Z, W. W, Z, Y. And then W, 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 W. Whew. Alright, there we go. So, this is still mad. Because I forgot the const. Okay, there we go. So that is the plan. It looks pretty good. Yep, it looks fantastic. Alright, cool. So the vec3 multiply will be basically the same. Excuse me. The vec3 multiply will basically be the same, except obviously we won't have that last one. And what's important to note is, apart from not having that last one, it will simply just not have this other.w, since other.w is a 3. Okay, that's really the only difference. So we can just basically delete that. All right, and that's it. That's our entire master plan. Okay, there we go. So that's the idea. We now need to implement the overloaded operators. So if we go down to our friends, which are right here. No, they're not. Yes, they are. These are it. Yeah, these are it. So we'll go ahead and they should be under. We'll go ahead and just implement that. So we had a vec3 and we had a vec4. Thought I'd just kill 2 birds with one stone and just implement both of them straight away. Again, we don't really need the vec4 yet, but we will. Okay, so left dot multiply right, and everything looks good in the hood except for these. So let's go back here quickly and just copy these. Alright, cool. There we go. So that's looking pretty good. Yeah, we're basically done. Okay, cool. So now that we've got this, we can go back into our simple renderer, our batch renderer. And this should now not be a problem. But it is. And this is what? This is vec3. So no meshes. So what are the maths? Oh. Okay, one thing I should do is I should get the batch renderer. Oh, sorry, I should get the renderer to have const matrices. where is... Yeah. We don't... Whether or not we want references is another problem. We don't really want references because... Yeah, we don't really want references. So we probably do want this to take in a const reference, but when we push back, it's not going to be pushing back a reference. Okay, that's an important note as well, because we kind of do want to copy it as well. So that's another important thing to mention. Now this is still sad. So why is it still sad? That's a vec3 reference. That's yeah, that's going to be a map4. And yet we're still very sad. That's a bit weird. Let's just try .multiply and see where the problem lies. So that's fine. So what's wrong with our operator? Suspicious. Very suspicious. So const mat4 reference left. It shouldn't matter. That should work. Weird. Let's try the next one with that. Whoa. So now it's working. So what's position? Position is a const reference. Interesting. So let's float back here. Oh, it's not const. Whoops. And here it was. Okay, that was my mistake. I even did declare it const here. Lol. Okay, so now it should work. Yay. Okay, so there we go. Let's just change this to take this stuff in. And there we go. Alright, cool. So now we're multiplying everything with the back of the transformation stack. Let's just run this and see if it works properly. So we should get the same result right now because we're not doing anything. Yep, looks pretty good. Except the performance is now terrible. This will affect performance, by the way. It shouldn't have affected performance that much, though. That is suspicious. Let's quickly switch into release and see what it's like. Yeah, that just decimated our performance, though. So it's fine in release. Well, I guess we'll be mostly in release mode from now on. I mean, we don't need to be continually drawing 50,000 sprites. So I'm going to just say if oh, yeah, okay. So we can do optimizations to this as well. But what we'll do is we'll just say if test 50k. We'll just do that. So I should probably say sprites as well. Okay. Okay, so now we're not doing that. Let's add Well, I mean, I do want to do something similarly to this. Let's just add like not as much, basically, because I still want to have a bunch of sprites, just probably not quite as much. We just don't need that much. So 0.9. There we go. So that should be a good amount of sprites, and it shouldn't be too bad either. Okay, cool. So yeah, 5,000 FPS. All right. One thing I want to do quickly before we move on is I could. Okay, we'll do a quick optimization now to get it to run a bit better. But if I guess I'll just put an else. Oops. Lol. All right. So if we are testing the 50,000 sprites, you can probably see that in debug mode, our performance is very bad. It is like 10 FPS, which is terrible. One way we could improve this is by... So this back operator is suspiciously bad. So what we could do is we could just cache the result of this. So every time we push... let's quickly... where's our... Let's just close some of these things. I get so confused when looking at so many open things. We could basically cache this. So we could be like maths, mat4. We could just make this a const reference as well. We could just call this m transformation back, right? Yeah, we probably have to... I'm just going to make it a pointer. We'll say that every time we... So in this case, we'll set it equal to... Alright, there we go. So we've got... There we go. We've got that now. Why are you mad? You're mad. Okay. So, and then every time we do all this pushing and popping, we just need to update it. All right. There we go. And then we should add that to log. Okay. So there we go. So we update it every time we push and pop it, and that way, when we go into our bash renderer, we don't have to do this anymore. We can just go m transformation back, dereference that. And this should hopefully make it a bit faster. Right now, remember, we're just doing identity. Yeah, so you can see how much faster it is now just by not using the vector's back operator, okay? So that's something that you should all remember. Okay, cool. So anyway, we're submitting all these sprites. Where are we submitting? Oh, they're in layers now, aren't they? So let's go ahead and, just for fun, let's go into our layer. So it's a tile layer. And, I don't know, we'll just go renderer. This will be probably best done in... See, this is where it gets a bit annoying. It's good with groups and whatnot, but we'll probably go ahead and say over here when we're submitting all of these. So right now, we'll just try it out and we'll say something like mRenderer dot or arrow push. Let's just do a translation of like 5. So alright. So we're pushing this, and I guess we can probably pop it like here. Oh, well, we need to flush it first. No, we don't. We just need to submit it, yeah. Pop it here. See, if it was the other renderer, we probably would need to actually wait for flash first. But okay, so that seemed to have worked. Now let's try it for varying sprites. So I can just go int I equals 0. So we'll do it for every second sprite. So we'll go ahead and say in our submission here that we'll just say I++, or in fact we can just say if I mod 2 equals 0, then let's we can probably get rid of this pop as well. We'll do that. We'll submit. We'll do it 5, and then for the other one, or in fact, I can just do 5 0 0 5. This will look weird. This will definitely look weird, but it's a good way to test whether or not this is working. So if we test something like this out, apart from performing quite terribly now because we are changing each and every sprite, you should see the awesomeness of the translation and whatnot. It doesn't seem to be affecting everything though. That's a bit weird. Let's so we're translating by 5. What if we do I? That would be really dangerous. Well, not really. We'll just probably lose most of them off the screen. Yep, they're all gone. Okay, so anyway. Where's my layer? Where's my layer? There it is. Anyway, that should pretty much be the case, okay? So there's our transformation stack. We can do it a much better way of... So unfortunately, the only thing right now that we have to do is basically have it in almost per sprite because of the fact that it's in the layer. So if we wanted, we could probably do something like this, but let's actually try and do something kind of real world and see it work for that. So if we turn that off, so let's just say I have a button. I have a button that just happens to be at, so we'll pretend we're making some kind of GUI and we've got a button at like 2, that'll be the middle one, so minus like 15, we'll have it at like 8, it'll be I don't know, 2 by 1, and the color will just be like white or something, I don't know. Alright, so if we take a look at this, okay, there it is. So the lighting's being a bit annoying, but was our other, let's not render layer 2. Okay, so I should have said 7. Alright, so there's our button. It's supposed to be white, but it's not because of the lighting. So we could, let's just say we wanted to add something into it. So it's a bit small right now. Let's just make it 4.2 or something. Yeah, that's still a bit small. 6.3. I'll drop it to like here. Okay, so there's our button. Okay, with, let me just change the lighting to work a bit better. So that'll be a quick, dirty way to do it. Or not. This is our normal shader. We're using a normal shader for that, aren't we? Yep. Oh, my lighting. My lighting is just not working with me today. There we go. So we've got this. Let's just set a... Oh, these videos are just so long. I don't mind them being long. It's just they take forever to render. Anyway, let's just say we add a we want to have a button or another, let's just say a pink like component inside that thing. So what I would like to do is say something like I want it to be at 0.2 with a length of, so our width and height is 6 and 3, so we'll make it like, if that we might just say 0.5. We'll make it like 5.5 or something, just 5.0 basically, and then for this we'll just make it 2.0. So I want this one to be inside this one, okay? And I want it to be pink. That's our plan. Right now obviously it's not going to work. It's going to put this one here. I want it to be inside this though. So how can we do something like that? Well, what we want to do basically is the usage of this is we kind of want to be like layer.push a matrix. So a matrix that is basically, if we make a sprite, we want a matrix that is made up from this position. We want to push that, right? And then at the end, we basically want to pop it. Okay? This is where it becomes a bit complicated because we want to basically say that, do we want sprites to be tied with this? Well, no, because we just want a bunch of things to be tied with this. And it becomes a bit complicated because we need to know what matrices are, like, essentially apply to what things. So let's say if we go to okay, yeah. So if we go to layer, what we kind of want it to do is for each renderable, we want to kind of basically see what all it does right now is it submits the renderable to actually be rendered, okay, but it doesn't actually access the transformation stack of the renderer. So what it should do is it should check out which renderable it's doing, add the stack to that and whatnot, and it should basically act that way. So the problem we have here is how do we get it to be relative to that without because basically when we're submitting this, we do want to be using push and pop based on what we're doing, but it kind of becomes a bit impossible with this whole let's just render them all at once kind of thing, okay? That is where groups are going to come in, okay? So fear not, that will be the whole scenario of groups, which we're going to cover next episode. All right? So if you guys enjoyed this episode, please hit the like button, and I'll see you next time. Goodbye. Whoa.